people. Good morning, good afternoon, good evening, good night. Welcome to the grand finale. Today we are going to finish our videos on the Physics 111. It's been a great pleasure for the whole team. We have been supporting you through different platforms, WhatsApp, eCanva, email, internet, whatever was available for us. You have been covered for almost 24/7 by this great team composed by Dr. Herbert, Earl McDonald, Ian Schroeder, all the tutors who have been working very, very hard to get you all the support you needed. And so far, we have been very pleased with your performance, and you have been great for the conditions that we are in. So I am very proud of you. So let's get the end of the year, the end of the semester done. And as you know, most of us are a little bit burned out. So let's look at what is happening, actually, the real situation. So obviously, now the problem is to all this marking, and we have our instructors under huge pressure because they have to mark lots of tests. Imagine the situation where you actually submit 4 PDF for one test, so we have to go through each of the PDF. So it's not like an easy peasy thing, because even for our expert team, it's difficult to open all these JPG files and get all the things marked. So luckily, through Canva, we figured out finally how to do this online test, these quizzes and tests, so things have become easier. But the situation hasn't been easy at all, although we have enjoyed the experience very much and having you around for this whole semester. So remember, being bucket is the physicist's best tool. And obviously here we have our instructors who are about to start marking all these tests, when suddenly our favorite instructor here, Sir Isaac Newton, is thinking what to do, because he's burned out quite a lot, right? So he's wondering himself how he can escape all this marking. And he figured out something very important. As we know, the work, this is W for work, is equal to the net force, which we also call it the sum of all the forces, right? Times the distance it takes is acting on that object. Say we move from here a distance, whatever it is, d. So if we apply a force onto this object, the force times the distance that we have taken for the object to move from position 1 to position 2, that will be the work done by that force. But then Newton starts thinking, how do I get rid of this marking? So he starts, and then he says, okay, let's apply my second law. So basically we have mass times acceleration, that's the sum of the forces, right, times d. But then we know for the uniform accelerated motion that v final square is equal to v initial square plus 2 times ad, right? So basically we can have substitute the whole d there, right? So D will be this is going to be equal to MA, and D will be equal to V final square minus V initial square. This goes there, and then divided by 2A. This 2A goes to the other term, dividing. So as you can see, MA goes away, and this results in m half, 1/2 of m mass of the object, final velocity, minus 1/2 of mv initial square. And this is, as we know, this whole term is the kinetic energy final minus the kinetic energy initial. So the work done by a net force applied on a distance d is equal to the change in kinetic energy, right? So this is what Sir Isaac Newton is thinking. Here we go. He's thinking all this while he looked at the bin and at this pile of exam papers, right? So then he suddenly realizes that the best thing is to run. Run, Forrest, run. This is the strategy that Sir Isaac Newton is implementing, and he does it very fast. He does it very fast. So he runs in a way that Albert Einstein here, he doesn't realize he's just run away, because he actually put a distance d here, a velocity final, a very big vf square compared to the initial velocity, and he is actually doing some work already. So as he's doing some work, Albert Einstein is going to be marking all the tests by himself, and this is what Sir Isaac Newton is doing. Obviously, he's going to his favorite place where you can find the nice apple with the worm, and finally we can even make some nice grass here. Let's make some nice grass there. And this is the story of what we call let's make it here, the work energy theorem. As you can see, the work energy theorem states just like that, where we have just learned that work is equal to the net force on the distance d that you move away, you travel, or then you move something, and this is equal to the change in the kinetic energy, which is given by 1/2 of mass v final square minus 1/2 of mass v initial square. As you can see, Albert Einstein has decided to run away. Poor guy is burned out, and with this, my friends, we are going to leave it there. Again, as I say, we are all very proud of you. We wish you do very well in the final exam. Okay, and remember always to eat lots of apples, lots of oranges right now. Oranges are very important for our vitamin C, and we have to be strong for the final exams. Okay, it's been a pleasure, as I mentioned before. And actually, I wanted to tell you one thing, one little exploration which I've been investigating lately. There was another pandemic. This is our instructor, Sir Isaac Newton, in 1664-65. There was what it was called the bubonic plague, and there was another pandemic happening in all over the world. And then Newton has to go to his village with all these apple trees everywhere, So then he has the time actually to focus, and he made most of his big discoveries. He made it in isolation through this lockdown. So I wanted to let you know that we have to take things as a challenge, but also to look at the possibilities that we have and see. Obviously, we're not going to be like Isaac Newton. We just can be better. So, but this is what I say, that we can look at the positive side of life always, prepare ourselves as much as we can for the test. Thank you very much, and all the best. It's been a great pleasure.